Hello and welcome back to Higher Maths, Polynomials and Quadratics, looking at the discriminant. So we've just covered question 3 in the previous video. I'm going to have a look at question 4, which is definitely a higher question. Show that this equation has real roots for all real values of k. Okay, so for real roots, we'll need to show that this is always going to be greater than or equal to 0. Okay, so looking at that to start with, we might be thinking, well, how on earth are we meant to do that? So we're looking for an answer that is always greater than or equal to 0, so it will be bracket squared. Remember, guys, so even if you've got a negative term inside that bracket, if you're squaring it, it will become positive. And then plus c where c is greater than or equal to 0. So it might be bracket squared on its own, it might be bracket squared plus 1, bracket squared plus 17, bracket squared plus 3. Because if you've got something that is either 0 or positive, and you add a positive number to that, then it's going to be positive. So even if it was 0 and we added on 3, it would become positive. Okay, so that is the format of answer we are looking for. So let's have a go at the question. So show that this is real roots for all values of k. So we're seeing that phrase, real roots for all values of k. So hopefully we're thinking, let's use the discriminant. So a is the coefficient of x squared. So it's what we have multiplying by x squared, so it'll be 2k plus 4. B is the coefficient of x, and C is anything that does not involve an x or an x squared. So C will be k minus 2. Next step, substitute in. Now at this point, this is why we've done all of the algebra practice in the essential skills exercises, okay? So that should not go to waste. This is why we got you guys to do all of this. When we come to a question like this, we can focus on the higher part of it, and we're not worrying about National 5 skills that might be a little bit not quite secure as what we'd hoped. Okay, so if you've done the work, this is when it starts to pay off. So bracket squared, bracket multiplied by bracket, then use FOIL, or first term multiplied by first term by second term by first term, second term by second term. And then here I would multiply the brackets together. And we have a minus 4k plus 4k, so they're actually going to cancel each other out. So that's just 2k squared minus 8. And then I'd multiply all of that bracket by the minus 4 at the start. So the minus 4 multiplied by 2k squared, the minus 4 multiplied by the minus 8 will give plus 32. And then at this stage, we tidy up. So we get k squared plus 12k plus 36. So because of all the completing the square questions I've done, I'm looking at that thinking, oh, that's just k plus 6 all squared. And some of you guys might be at that level as well. If not, because we know that we're looking for something like this, let's factorize that, which is k plus 6 all squared. So b squared minus 4ac is equal to bracket squared, which is greater than or equal to 0 for all real values of k. Therefore, the roots are always real. So I'll just go over that bit again. Let's take some values of k. If k is a positive number, so for example 3 add 6 is 9, 9 squared is going to be greater than or equal to 0. If we take k as being 0, 0 plus 6 is 6, 6 squared again is a positive number. If we take k as negative 6, negative 6 plus 6 is 0, 0 squared is greater than or equal to 0 because it is equal to 0. So that is going to give a number that is not negative, so therefore there will definitely be real roots. And even if k was, say, negative 10 plus 6 is negative 4. If we square negative 4, we get positive 16, which is greater than or equal to 0. Therefore, we're always going to get something that's greater than or equal to 0. So we're always going to get real values for all real values of k. So they're always going to get real roots, whether it be real and equal or real and distinct roots, but we will always get real roots.